Hello everyone. In this moment, you have learned the fundamentals of B plus tree and indexing. I will talk about the insert and delete key value of B plus tree.
In this section, we'll talk about how to insert key value in B plus tree and also delete key value in B plus tree. So first of all, let's move on to see how to insert key value for B plus tree. Here is the insert algorithm. So the first step is you should find the correct leaf, which is you should decide the value should put it on left hand side or right hand side. After that, you can put data entry onto leaf. If the leaf has enough space, your operation has already done. Otherwise, you must split the leaf, which is you should split the leaf into leaf 1 and the new node leaf 2. After that, you should redistribute the entity evenly by copy up the middle key. I will talk about this operation and concept later on by example. After that, you should insert index entry into parents of leaf and pointing to leaf 2, which is the new node. You should remember that this operation can be happen recursively. To split the index node, you should redistribute the entity evenly but you should remember to push up the middle key. You should remember that this operation is happen in index node. After you finish this type of operation, you can see that your tree will get wider and one level taller at the top. So here you can see the example of the B plus tree. When we want to add 25 into this tree, which leaf can we choose? Of course, you can choose the leaf which is contain 24, 27, and 29. So you can see that there has enough space for 25, so the operation has already done. After that, if we want to add 8 into this tree, we can see that when we add the 8 into the leaf of 2, 3, 5, 7, there has no enough space for us to insert. So how can we do? As we mentioned, we can copy up the middle value of this node and split it to leaf 1 and the new node leaf 2. After that, you can see that there has enough space for 8 to insert. But you can see that after the copy up operation, the index node has no enough space for 5 to edit. So we can also push up the middle key of the index node, which is 17, and then push up. You can see that there has one more level of the B plus tree. So the whole operation of the insert has already done. So let's move on to the second part of the B plus tree. It is the delete key value in B plus tree. So here is the delete algorithm for the B plus tree. First of all, this operation start at root. You should find the leaf where the entry belongs, and then you should remove the entry. If the list has at least half full, you should remember it's at least half full. The operation has already done. Otherwise, if the leaf has only d-1 entries, so you should try to redistribute and borrowing from seedlings. And if redistribution fails, you should merge the leaf and seedlings. If the merge occurs, you must delete the entry which is pointing to the leaf or seedlings from the parents of the leaf. So when you finish this operation, you can find that the propagate to the root and decreasing the height. So you can see that here is the example of the deletion of B plus tree. If you want to delete 19 of this tree, you can see that you can just delete the entry and then check is it fulfill all requirement of the algorithm. Yes, because if you delete the 19 in this leaf, it also has at least full in this leaf. After that, if we want to delete 20 in this leaf also, you can see that we should do the redistribution, because when we delete 20, there cannot fulfill the requirement of at least half full of the leaf. So we should copy 24 in the leaf. You can see that, and the 27 will go to our parent leaf node. And then you can see that after we do this operation, we can fulfill the requirement. So let's redo the last deletion, which is we want to delete 24. If we delete 24, you can see that the leaf of the 24 has only contained 22. So here cannot fulfill the requirement, at least half full. So we should do the merge. How can we merge? We can merge two leaves, which is 22, 27, and 29. So when we merge the leaf, you can see that the parent node cannot fulfill the requirement, which is only contain 30. So we should merge the parent node also, which is 17, 30, another leaf. So after we merge the parent nodes, we can see that the b plus 3 will change to this form. So here is the example of the deletion of the b plus 3.